Namaskar. It gives me immense pleasure to introduce you to the Indian Plumbing Association's Plumb Talk series. As part of Plumb Talk, plumbing industry experts from across the country will be explaining the nuances of plumbing technology in an easy and understandable manner. And this will make plumbing science easier for building industry professionals, engineering and architectural students, as well as the general public to understand the basics of plumbing technology. Let me give you a little background on IPA, which is the apex body of plumbing professionals in India. IPA is now a 29-year-old body started in 1993, currently has 24 chapters working towards redefining plumbing standards in India, tirelessly working towards better plumbing for a healthy living. I therefore request you to please go through the Plumb Talk series, which will be a guide for students, for architectural students, for even current architects and engineers, so that you are able to improve your knowledge on plumbing and ensure that all plumbing installations are installed not only as per codes, but we make sure that whatever water we use, we move towards net zero water and net zero sanitary waste.
Hello everyone and welcome to the Plumb Talk Series 1, and today we are going to study Chapter 3 on Basic Planning for Plumbing from IPA's publication, A Guide to Good Plumbing Practices. A poor plumbing system can cause leakages as well as wastages of water and major damage to the property in the future. To avoid all such problems, you need to ensure that plumbing systems are properly planned and installed. Now let us go through the basic planning requirements for a good plumbing system in different steps. To start with, identify our plumbing requirements. First of all, the construction methodology shall be identified, whether it's a conventional RCC structure, prefab construction, concrete walls, PT slabs, flat slabs, or dry walls. This plays an important role in basic planning of a plumbing system. Thereafter, present and future plumbing requirements shall be identified. The locations for drain lines, water lines, hot water systems, water tanks, water treatment rooms, sewage disposal, and rainwater disposal shall be finalized so as to ensure functionality, accessibility, and future repairs, if any. The quality of water plays an important role in any plumbing system, and so water from all possible incoming sources shall be tested from a recognized laboratory prior to installation of plumbing systems. Upon receiving the test results, the extent of water treatment required shall be finalized in consultation with a plumbing professional. Now let's look on water tanks and pump room planning. Identifying and planning water tanks and pump room spaces at the initial stage of a design is very important. The pumps shall be planned so as to have positive suction for better efficiency of the system. As far as possible, negative suction shall be avoided. To achieve this, ensure that the pump room bottom is always lower than the water tank bottom by a minimum of 450 mm. In case pump rooms are not possible below ground, only in that case negative suction with pump room on the top shall be preferred. However, care shall be taken to calculate the NPSH of pumps while deciding the depth of the water tanks. Tanks can be in the margins if the local norms permit, or within the basements depending on overall planning. Recommended water depths shall be maximum 4.5 meters and pump room height shall be minimum 3 meters. The water tank manholes can be top entry or side entry depending upon the project requirements. More details on this shall be covered in our next video on water supply. Basic space planning for sewage treatment plant. Now STPs is normally planned in the lowest side of the project or in the basement and mostly towards the line of sewage disposal from local authorities. As a rule of thumb, 5.5 meters to 6 meters of height is required for STP. Depending on the capacity of STP, the area required is calculated by the MEP consultant, but as a rule of thumb, we can consider area equivalent to volume. For instance, if the STP capacity is 200 cubic meter, plan 200 square meters of area. The negative spaces of the basement shall be utilized for STP. An exhaust system will be required for each STP area, and so adequate shaft as per the consultant's requirement shall be provided. Now let's look into the basement drainage. A drain trench or a channel at the upper and the lower level of each ramp shall be planned so as to trap the rainwaters. Additional drain shall be planned within the basement so as to trap the accidental fire sprinkler bursts, car wash or basement wash. These drains shall lead to adequately sized drain sumps fitted with submersible pumps planned below the lowest basement floor level. Now let's look at the locations of washrooms, kitchens and utility areas. Ideally, all wet areas like washrooms, kitchens and utilities shall be located in close proximity to minimize the pipe work and other associated plumbing installations. It is always recommended to plan washrooms and kitchens towards the exterior part of the building to ensure natural light, ventilation, ease of installation and serviceability of pipework in future. In multi-storied high-rise buildings, these areas shall be ideally located exactly one above the other so as to achieve vertical continuity of the plumbing shafts from top terrace level to lowest level so as to amplify the water supply, drainage, rainwater, pipeworks. Plumbing shafts shall be planned with respect to the plumbing fixture layouts within the washrooms, kitchens, etc. Shafts shall be truly vertical, continuous and preferably of the same size from the lowest point of basement or ground floor to the roof. Plumbing shafts will require access at every floor level. The minimum width of access shall be 600 mm and the minimum height of access shall be 900 mm, though minimum 1200 is preferred. Ideally, the access to the shafts shall be planned from common areas of the building so that for any future requirements, entry to the private spaces can be avoided. For high-rise or multi-storied buildings, a shoot-to-site access platform shall be planned in the shaft so that it helps for any future repairs and maintenance. Now let's look onto plumbing shaft sizing. There are no guidelines or code requirements indicating what is an adequate shaft size. However, each plumbing shaft shall be sized so as to accommodate services dependent on project requirements. Domestic water supply pipes, one or more. Flushing water supply pipes, one or more. Hot water supply pipes, one or more. Hot water return pipes, one or more. Isolation or control valves. Domestic water supply riser pipes to overhead tank. Flushing water riser pipes to overhead tank. Rainwater downtake pipes can be one or more. Soil stack can be one or more. Waste stack can be one or more. Vent stack can be one or more. Shaft drain, shaft access door, toilet exhaust, working platform. These are the services which are to be placed in the shafts. Some additional services like water heaters, flush tanks, HVAC pipes, artificial ventilation, artificial lighting can also be accommodated in the plumbing shafts. Looking to all these service requirements, the shaft sizing shall be done. Coordination with other services such as heating, ventilation and air conditioning pipes and ducts shall be done at the planning stage. Our codes and regulations do not allow installation of firefighting, cooking gas and electrical services within the plumbing shafts, and therefore separate shafts shall be planned for this. In high-rise buildings where access to shafts cannot be achieved from each level, provisions shall be made in the form of cat ladders or rungs within the plumbing shafts for the maintenance persons. High-rise building fire regulations stipulate sealing of internal plumbing shafts at every floor level. In such cases, shaft drains shall be provided at every floor level. These shaft drains can be used to handle dripping of water from air valves, small leakages, and also for condensate drains of air conditioning units. Obstructions by structural members such as beams, columns within the plumbing shafts must be avoided by proper coordination with the architect and structural consultant. Now let's go through the bathroom planning, whether sunken or suspended drainage. It's a $1 million question as to what shall be done, drainage through the sunken slabs or suspended drainage. We should leave it to the plumbing professionals, architects, and the end user to decide on this, since both the systems have their pros and cons. Hence, a cautious call shall be taken at the initial planning stage while deciding the drainage system so that the structure can be designed accordingly. In case of sunken floor drainage, it is recommended to have a minimum sunken of 300 mm or as to have proper drainage with a flow trap of minimum 50 mm water seal as per NBC and UIPCI. In case of suspended drainage, it is recommended to have a sunken of 75 mm or 100 mm so as to have sufficient space for proper slope, flow drop, and waterproofing treatment. In both the cases, appropriate waterproofing treatment shall be carried out as per the expert advice of plumbing professionals. Now we move on to the sizes of washrooms, kitchens, and utility areas. For sizing of washrooms, kitchens, and utility areas, a close coordination will be required between the end user, the architect, the interior designer, and the plumbing professional. Minimum sizes of washrooms, kitchens, and utility areas shall be determined based on the types and number of fixtures and their preferred layouts within. Washrooms and utility areas shall be planned with respect to the selected plumbing fixtures and appliances such as cloth washers, dishwashers, etc. Kitchens shall be planned keeping space provisions for dishwashers, refrigerators, cooking ranges, ovens, working platforms, etc., apart from sinks and storage cabinets. A typical residence will usually have bathrooms, shower rooms, and powder rooms. While sizing a bathroom with a bathtub, the size of the tub is of extreme importance as these are available in different sizes. The smallest ones usually of 750 mm wide and 1500 mm length. The other fixtures shall include a water closet, a vanity, or a wall-mounted wash basin, and in some cases a bidet. In the case of shower room, there can be an in-situ shower area, a pre-engineered, ready-to-install shower cubicle, or even a shower tray depending upon end user's requirement. A powder room shall have a water closet and vanity, all wall-mounted wash basin. The UIPCI provides guidelines on minimum spaces required around the plumbing fixtures to ensure user comforts. Referring to these guidelines and taking into account the fixtures described above, a rectangular shaped washroom is preferred over a square shape. A bathroom or a shower room of a minimum finished length of 2250 mm and width of 1650 mm will facilitate installation of bathtub or a shower, a water closet, and a wash basin with reasonable user comfort. This takes into consideration a clear width of 800 mm for a bathtub or a shower, 850 mm for a water closet with 425 mm from the center of either sides, and 600 mm for the wash basin. The length of 1650 mm also takes into account ease of locating the door and opening of the door shutter without any obstacle. The shape of a powder room consisting of a water closet and a wash basin can be square or rectangle with minimum sizes of 1500 mm by 1500 mm or 1000 mm by 1650 mm or 2250 mm by 1650 mm. The shape of a room with only a water closet can be rectangular with minimum size of 900 mm by 1500 mm. The sizes explained are all indicative and can be used as guidelines. The final layouts of washroom interiors can be customized by an architect or an interior designer as per the end user's requirement. Now let's move on to the standard mounting heights of the plumbing fixtures. Based on the average heights of Indians, the fixing or mounting heights are uniformly followed throughout the country. However, these heights may vary a bit as per the end users or the designer's requirements. Some of the commonly adopted dimensions are for European water closets, including seat 375 mm to 425 mm. For wash basin up to the rim, it should be 800 to 850 mm. For kitchen and utility sink, it should be 800 to 850 mm. For a bowl urinal up to the lip, it should be 500 mm to 600 mm. For shower mixers, it should be between 750 to 1000 mm. For shower heads, 1800 to 2100 mm. The spout should be at least 100 to 150 mm over the top of the tub. The ablution faucets, 400 to 450 mm. These dimensions are all reference to the finished floor level. In children's toilet, in a private residence, schools, hospitals and public places, the height of WC shall be 300 mm and height of urinal shall be 450 mm. In the case of toilets for disabled, the height of the WC shall be 450 mm. The layout of a toilet and mounting heights discussed here will vary for differently abled persons and it shall be covered in a separate video. Floor mounted water closets, full stall urinals and wash basins with full pedestals will have predetermined mounting heights as per the manufacturers. The height of flush walls and actuator plates of concealed flushing systems for water closets shall be fixed, ensuring that the seat cover when upright is not obstructed. Plumbing fixtures and fittings include water closets, bidets, wash basins, bathtubs, showers, sinks, water heaters, ablution faucets, sink, wash basin mixers, and washroom accessories such as towel racks, towel rails, towel rings, toilet paper holder, soap dishes, rob hooks, cloth lines, shower curtain rails, etc. Public toilets will additionally have urinals, soap dispensers, hand dryers, mop sinks, etc. Generally, drinking water stations are also located outside the public toilets. It is very important to finalize the make and models for all such plumbing fixtures and fittings prior to starting the design of the plumbing system for the project. Flushing devices for water closets, shower mixers or diverters, bathtubs and basin mixers are extremely important fixtures affecting the pipe sizes and design of the entire plumbing system. The plumbing connections and subsequent design of water supply and drainage pipes will largely depend upon this information. Now let's look on to the water closets. Water closets commonly used include the European, Asian or Indian squatting pans and combination types. European water closets are differentiated by the mechanism of flushing as siphonic type and wash down type. In siphonic type WCs, the flushing happens through siphonic action due to the specific design and construction of the pan, whereas in wash down type WCs, the flushing action happens through the force and volume of water used. European WCs can also be differentiated based on mountings as floor mounted or wall hung, or commonly we say wall mounted. Wall hung WCs facilitate cleaning of floor below the pan and so are widely preferred. While installing the wall hung WCs, correct height and fixity to the wall shall be ensured. Use of purpose-made carrier frames or brackets are also recommended for the installation of such wall-hung WCs. In case of WC models which are to be mounted onto the wall, using expansion bolts, stability of the wall shall be ensured. If required, additional concrete blocks can also be used for fixing the expansion bolts. Asian or Indian squatting pans have detached flushing devices, and so care shall be taken to ensure that the cistern and the pan function efficiently in conjunction. European water closets have integral traps, whereas in case of Asian or Indian squatting pans, appropriate compatible traps shall be added. Flushing mechanism for a water closet can be a cistern or a flush valve. In cases where flushing mechanisms are not part of the toilet chutes and are selected separately, the combination of the pan and the flushing devices should be ensured. European and combination WCs come with seats and covers of various materials such as plastics, ABS, wood, etc. They are also available as soft close options for European WCs. Ablution fixtures. Asians have considered water to be essential for ablution due to hygienic considerations. In the past, a beep tap used to be provided near to the water closets, whereas the current trend is to use a handheld trigger spray with a flexible hose and a stopcock, usually located on the right of the user when seated. Various models of water closets are currently available with ablution sprays integrated with the closet seats and independent units added under the seats. Such ablution sprays do not have a backflow prevention device incorporated as a part of the unit, which may cause contamination of the water distribution system, as these are in close proximity with the water closet pans. Since the ablution device needs to be connected to the domestic water distribution system serving wash basins, showers, kitchen, sinks, and drinking water sources, occurrence of back siphonage may cause serious health hazards due to contamination, and so it is advisable to use backflow prevention device when using the ablution sprays integrated with the closed seats and independent units under the seats. Several researches have established that manufacturing of toilet paper involves environmental degradation due to the deforestation, as timber is used as the basic raw material. Additional research by the plumbing industry has established toilet paper as one of the prime causes for blockage of drains, especially in the current scenario when the focus is on water conservation through low flow fixtures. A decrease in flow of water in drains and the addition of toilet paper with high wet density adversely affects the self-cleansing velocity in the drainage system. Consequently, this aggravates the problem commonly termed by the plumbing professionals as dry drain phenomenon. When this occurs, there is a tendency for the liquid to flow without carrying the solids, along with it leading to the blockage. Bidets. Bidets are the ablution fixtures manufactured in Vitreous, China, installed in close proximity to the water closets. Bidet can be floor mounted or wall mounted to match the design of the water closet pan. Bidet mixtures with spray heads are not at all recommended due to the concerns of contamination of the water distribution system through the submerged spray heads. It is always recommended to use a deck mounted bidet mixture with a spout. Bidet outlets are recommended to be connected to the soil drainage systems with appropriate traps. UIPCI stipulates a relatively lower temperature for bladed water for usage in bidet in comparison to the other fixtures. Now let's look on to the urinals. The urinals currently available are categorized as bowel urinals and stall urinals. Trough urinals are prohibited fixtures as per the provisions of UIPCI. Flushing mechanisms used with urinals are flush valves or sensor-operated electronic flushing devices. When flush valves are used, a vacuum breaker shall be an integral part of the unit. If STP recycled water is used for flushing WC, the same shall be provided for flushing of urinals. Urinals shall always be connected to the soil drainage system. Waterless urinals are currently used as a means towards water conservation. Waterless urinals incorporate a cartridge, a floating liquid, or a mechanical device to replace a water seal used in the conventional urinals. Water Efficient Products India, WEPI, and IPA Ahmedabad publication stipulates several precautions to be considered while using waterless urinals. Now let's move on to the overhead water tanks. The overhead tanks shall be sized based on the overall water supply demand and the type of water supply distribution system being planned for the project. The tank partitions will have to be based on structural considerations, different quality of water to be stored, and water requirements for firefighting, if applicable. The storage tank compartments containing domestic, potable, and reclaimed or flushing non-potable water should have adequate sanitary separation. Now let's look onto the safety features for selection of materials. Sanitary fixtures manufactured of impervious material such as white china, fire clay, glass, stainless steel, or plastics of approved quality shall only be used. While selecting white china sanitary wares, the quality of glazing shall be taken into account since the substandard glazing will encourage microbial growth. Only BIS certified or equivalent products shall be selected. The flooring material selected in the wet areas shall be of non-skid type, but at the same time it shall facilitate smooth flow of water. The fasteners of bracket shall be selected appropriately with due reference to the manufacturer's recommendations. It is recommended that the walls of toilets or the washrooms be built with bricks or solid blocks instead of hollow blocks to ensure adequate stability of the fixture. As an additional measure of safety, concrete bands or blocks of adequate width and depth may be provided where fasteners are used. Let us look on to the safety features to be taken care for installations. The installation of fixtures in washrooms shall be such that free access and movement shall not be obstructed. Washroom accessories such as toilet holders shall not provide into minimum space for water closets as stipulated earlier. Similarly, installation of a soap dish and dispenser in a confined space of a shower cubicle shall be such that the free body movements are not impeded. Towel racks and towel rails over the bathtub shall be suitably located to avoid the accidental injuries to the user or obstruct the movement of the door shutter. Grab bars at showers or bathtubs or water closets shall be adequately secured, ensuring safety of the users. So with this, thanks. This is Minesh Shah, a proud IPA member, signing off. See you soon all for the next interesting episode on Plumb Talk. Good day for now and have a wonderful time ahead.